So before I start, who out there has actually heard of NANOG before? Oh, cool. How many of you read the mailing list? Oh, a few. Okay, well, I'm going to try to talk a few more of you into it, and also into joining the conferences and a few of the other things that we do. So Bruce asked me here primarily to talk about what NANOG's opinion of IPv6 is. That's kind of a funny question because NANOG collectively doesn't have opinions. NANOG is a whole bunch of people who work together and spend a lot of time arguing about stuff. If you read the mailing list, you already know that. If you don't, well, listen to my presentation and you'll kind of understand why. So, let's see, what have I got? All right, I'm going to divide this into 3 parts. I'll also try to keep it fairly quick because I understand that there's a break after me, so I don't want to stand between you and the food. First, I'm going to talk about what NANOG is, why you should be interested. Second part's going to be an overview of some of the recent discussions about IPv6, both on the mailing list and at the conferences. And third, I'll give you a brief overview of what I think about IPv6 as an individual. So, with that said, NANOG is the North American Network Operators Group. NANOG started a long, long time ago, back in the dawn of the internet days, which honestly is the 80s, I guess, is about the right time. In those days, there was this thing called the NSF-net, which was, well, here's my next slide, talks more about it. It was a research and education network sponsored by the United States National Science Foundation. It was spun off from the original ARPANET, which was funded by the Department of Defense and still continued. But there was a lot of interest in using it as a research vehicle in North America and throughout the world, in fact. The NSF themselves built a backbone network operated by a company called ANS, which was a consortium of IBM, Merit Network, and I'm forgetting a third, which I'm sorry. Oh well. And a bunch of regional access networks that were more localized in scope and divided into a bunch of regions around the US. Those regional networks decided that they were going to have their technical people get together 3 times a year and meet and talk about stuff. And they started a mailing list. And a lot of the coordination in those days on what happened on the internet happened in those meetings and on those mailing list, on that mailing list. In the early to mid 90s, the internet transitioned to a commercial entity. The NSF decided to get out of the business of running the internet and founded a bunch of initiatives to spin it off and allow commercial competition to happen. As part of that, the regional tax group turned into NANOG. It was still organized by Merit Network, which was the group that had been running the regional tax. They had some funding from the NSF to keep it going for a while. Eventually that ran out and they had to be self-sustaining. But back in those days, it was actually kind of interesting. It was, the meetings were about this size. They were on a college campus. We had lunches brought in. It was a really good way for the people who were running the internet in those days to sit down and solve problems. And a lot of it actually happened. A lot of the big network changes happened during these meetings with, around the terminals, the computers in the back. A lot of the work happened in the bar too. So NANOG went along that way for a while. In 2005, a group of the operators decided that they would like to have more say in how NANOG worked, in how the programs were developed, in how the mailing list was operated. So after an interesting period of about 6 months to a year, it evolved to a form of limited self-governance. There was an elected steering committee. The people who participated in NANOG elected 6 people to represent them. And that steering committee selected program committees and the mailing list committees that did the work of assembling the conferences and policing the mailing list and keeping things running. That worked okay for about 6 more years. And then similar group of people decided it was time to split off NANOG into a completely separate organization and to be self-sustaining. So that means that as of about 6 months ago, NANOG is a completely separate 501c3 nonprofit corporation, has an elected board of directors, and most importantly, has full fiscal responsibility for making sure that the group survives. I'm actually proud to say that we had our first completely standalone meeting just this last month. I believe that we actually made a surplus on it, which is a big thing because it means that we can start building reserves. That's hugely important in the nonprofit business because it means that you can survive economic downturns or bad weather or whatever might impact your revenue sources. So, yeah, this is mostly what I just said. We're independent. We have an elected board of directors. I was on that board until my term limits ran out last month. So now I'm a retired board member, I suppose. We have a new chair, Sylvie LaPerriere, who I hope you all get to meet someday. She's doing an excellent job. We have a hired staff of people to run the organization, and we have a bunch of volunteers running the various committees. Same as before, except that, like I said, it's full fiscal responsibility, and so far, doing well. So one of the things that's important to realize, NANOG is not a standards body. NANOG doesn't say, okay, this is how things are going to work, this is how the protocol should work. IPv6 isn't specified in NANOG. There's groups like the ITF and ITU and a whole bunch of other bodies that get to do stuff like that. It's also not a governance body. We don't set policies. We have ICANN, we have regional registries, we have governments that want to do that sort of thing too. That's actually a whole separate topic and a very interesting one, which I'm not going to get into because that would take all day. NANOG is a forum for internet operators to exchange technical information. We have conferences 3 times a year, usually in some fairly decent-sized city in the US, although every now and then our Canadian friends remind me that Canada exists, especially with Sylvie in charge now, who's Canadian. So we're having a meeting next year in Vancouver. I don't think she'll get her way and have every meeting in Canada, but at least we will stop trying to have our meetings on Canadian Thanksgiving, which has been a source of pain for a few people in the past. We have a mailing list, which last time I checked was about 10,000 people strong. I encourage all of you to take a look at it. There's interesting stuff. There's not interesting stuff, but in my view, the interesting stuff outweighs it. There's a lot to be learned just by reading what people have to say. And one of the rules as you read is take everything with a slight grain of salt, because everybody is a self-proclaimed expert on everything. But not everybody agrees. So it's interesting to follow along the debates and try to decide for yourself who's right and who's not so right. The last point there, collaborating to make the internet better. We had a board retreat a couple of months ago where we sat down and tried to figure out, why are we here? What's the whole purpose of this NANOG thing? Why do we bother with it? And, excuse me, the guy who ran this retreat said, we don't want to come up with a whole long mission statement or anything like that. We wanted to come up with a short statement that you can explain to your grandmothers or your spouses or your people you meet in elevators, why we bother with NANOG. And that's really what it came down to, boiling everything down. We're a group of network engineers, operators, architects who get together, exchange ideas, and collaborate, and that's the big important piece of it. I mean, you're doing this here too. It's a very important piece of why the internet keeps running without a centralized authority running everything, because we collaborate and we work together to make the internet better. So now that we're a standalone organization, there's some stuff that we can do once we start building a reserve. We can expand educational offerings. Right now, the NANOG conferences have a half day of tutorials. That's great, but we'd like to be able to bring in perhaps more educators, bring in more newcomers to the industry and give them an opportunity to learn how to operate their networks. There's been a lot of talk about establishing a document series for best common practices. Again, this would be separate from things like the ITF do. It's not standardization so much as it is writing down ideas on how we could operate things in an efficient manner and how we could work together to do that. With money, of course, comes the ability to do more outreach and provide scholarships. So students or people from developing countries or a whole broad range of people can get involved to the group. NANOG. Right now, I don't know if you noticed, my hair is kind of gray. There's a whole bunch of people with the same colored hair in NANOG. One of the things we really want to do is bring in the next generation of network engineers so we can keep this cooperation going and making the internet better. So, I'm going to segue from that into a little talk about what we did in the last NANOG meeting. We met in Philadelphia for a couple days last month. It was a really successful meeting. There were a few talks that touched on IPv6 and also very related is IPv4 runout. Let's not forget that IPv6 isn't the technology just for its own sake. It exists because even 15, 20 years ago, people were already seeing that v4 was a finite resource, and at some point, 32 bits were not going to be enough. We're there now, and v6 is happening. So the two topics are completely intertwined, and you'll see more of that. So here are a couple of the things that happened at this last NANOG meeting about IPv6. We had a tutorial. Had a gentleman from Cisco who spent most of an afternoon teaching his students about how to configure, set up IPv6. Probably similar to some of the stuff that happened here yesterday. Greg from Brocade gave a talk. He every now and then gets up and talks about router architecture. He's really big into that. He's worked for a few hardware vendors over the years. One of the big deals in designing especially large-scale routers now is the size of the routing table. If you want to do fast routing table lookups, you need specialized hardware to do that. And as the routing table sizes grow, that hardware needs to get faster, better, bigger, all those things. And that's important because not only does IPv6, as you add a whole new routing paradigm to the global internet, it takes up space, but IPv4, as it runs out, is becoming more fragmented. And we're likely to see even more of that as people start trading IPv4 space and trying to maximize the usage of those last little bits. So there's some serious challenges to be overcome with routing table sizes and how that can be dealt with in hardware. So Greg talked about some of the work that's being done by the manufacturers and the researchers to try to make that happen. There was a talk about the impact of IPv4, IPv6 interworking on lawful intercept. Yeah, these are the guys in the government who want to watch what we're talking about. Of course, they do it completely legally, as she was quick to remind us, with search warrants and all. But it turns out that the presence of NAT in protocol translation in most of the current solutions for interworking causes problems. Once you have an end user behind a NAT or multiple NATs, how do you figure out where they are and who they are? Governments are interested in knowing that kind of thing. So there's work to be done in trying to figure that out. And to be fair, most network operators and manufacturers are cooperating with the government to make sure these things happen so that lawful wiretapping can happen. 3 more talks. This next one is actually my favorite, and it's one that I encourage all of you when you have a chance to listen to. The video archives from the last meeting are not up on the web yet, but they should be in the next few days. And when they are, I'll post them to my GoGo profile because I really want you to watch this one. Jeff Houston, who Eve mentioned a little while ago, is probably one of the best speakers on the planet. It's worth listening to him just because of who he is and the way he talks. Listening to him read the dictionary probably would be entertaining. But this was actually a fascinating talk, and I wrote some notes here because I don't want to forget anything. But, all right, let me start from the top here. All right, so he started off by talking about how the telecommunication providers have a long history of making bad choices. As an example of that, of course, was their insistence on how everything is a switched circuit path while people were overlaying the internet on top of it, and they ignored that. So the big thing that they have to figure out now is how to manage the transition of v4 to v6. So he wanted to offer them some advice on how perhaps to do it right. Spends a fair amount of time talking about the current transition mechanisms involving carrier-grade NAT, application gateways, all that stuff. All that requires capital investments. You have to buy new hardware to do that. The hardware manufacturers are loving it because they see dollar signs coming in. The providers also might be loving it themselves because they see all of a sudden they have a box in the network that's providing services, and that can help lead them toward perhaps captive audience. Yeah, interesting thoughts there. So one of the big problems right now is that the last mile v6 connectivity isn't quite there. You've mentioned that we're starting to see some traction now in the cable industry, less so in the DSL industry, but getting the end user equipment v6 capable and getting the things that they talk to v6 capable is a challenge, and that also requires capital investment. And at this point, the providers are doing what's cost effective for them. They see that it's easier to put these NAT things in the middle because it's less expensive, both in terms of capital and support costs, then that's what they're going to do. So, the other thing that Jeff mentioned, which is critical, I think, to understanding his point, is that v6 is running out, but it's not running out all at the same time. We've seen APNIC ran out of space earlier this year. So Asia Pacific, you can't get v4 space assigned to you in any real manner anymore. If you're a new up-and-coming ISP, maybe you can get a tiny bit. If you're a big one, you can't get enough to keep your business running. So in that region, they're being forced to do this carrier-grade NAT stuff and all the various solutions involving that. Estimates in the ARIN region where we are here, currently, according to his best projections, they're going to have space until 2014 sometime. So that's another almost 3 years before the space run out. So his worry is that because we're running out of space at different times, we're going to be seeing different solutions evolve in different regions. So the current best net technology being deployed in Asia Pacific region today might be very different from what gets deployed here in the US in 2 or 3 years. And his fear is that that's going to cause balkanization, different solutions, different parts of the internet that really aren't capable of talking to each other without this massive intermediary mush of middleware that makes it happen. So he urges us to not forget that the big focus here is we want to transition to v6. All these interim solutions really need to be interim. So as people who use the internet, people who operate the internet, we don't want to forget that. We need to push toward the end goal. Of course, his final statement was bring it on. Let v6 run out. Let's forget this whole issue of trying to just keep it running and bring it on. Let the transition happen, make it happen, and that'll force people to do it right. So I spent a long time talking about that because it is an important talk, and I do urge all of you to listen to that one, watch it. The next talk was about the economics of address markets on v6 deployment. It was mostly talk about economics. There was some math involved and things like that. But his basic point was that at some point, right now, v4 address space is relatively inexpensive. v6 deployment is relatively expensive. So the people who count money, which is anybody who runs a business, is going to do whatever's cheapest. And that means they're going to buy v4 space, they're going to invest in the carrier-grade NAT, whatever. And they have a financial incentive to keep v4 running as long as they can until some point in the future when when v4 space really becomes scarce and the cost of deploying it becomes too much. And that's the inflection point. That's where we're going to start seeing v6 deployments start really happening in earnest. So that was an interesting talk. The final one, Todd Underwood, one of my favorite people. This is another one worth listening to. But before you do that, you need to watch his talk from NANOG 49 in San Francisco last year, where he gave a talk about, let me see if I get this right. I don't have the title here, but it was basically using probability as a basis for IPv4 address assignment. His basic thesis was that if you, instead of just giving everybody v4 addresses, you give them the chance at a v4 address, and you apply, let me get this right again, you apply probability, wireless radio technology, a bunch of really cool math, and most especially some really good acronyms. You can end up with a system where you can keep v4 running forever and ever. Todd doesn't like v6, so he likes to come up with ways to do this. This talk, one of the most entertaining things I've ever seen at a NANOG meeting. Watch his first one, then watch this one, and you'll understand why I say this. Also at the last NANOG meeting, and the last few actually, we've had this thing called the NOG Lab, which is an area where a bunch of equipment and network providers get together and actually deploy some equipment and do a demo network. These are the participants from the last one. And here's the diagram, which you probably can't read. I don't know that it's worth it, but it basically shows that they built from the ground up an IPv6 enabled access network and content network and provided connectivity to the v6 internet at large. And their aim was to show that with the equipment that you can buy today, you can do v6 deployments. It is real, it works. You can talk native v6, you can use these NAT solutions, and they just work. I think most of the people were in the room playing video games with each other across v6, but that itself was a valuable demo. Other piece of what NANOG does is the mailing lists. So I'm going to just go through real quick. These are some of the recent topics on the mailing list that talked about IPv6 and address exhaustion. There was one a few months ago about NET 444 or question mark, and that got into some of the details of what the various interim solutions are and their strengths and weaknesses. It's a question about deploying IPv6 over a PPTP link. Somebody wanted to try that and asked how it was possible. So that's a good example, by the way, of why, even if you're fairly new to this, it's worth watching the NANOG list, because you can get, by reading these things, useful advice, useful hints on how to make things work. And don't be too afraid to ask beginner questions, because there's usually somebody out there who will help you. Don't be afraid, there's usually somebody out there who will complain that you're an idiot too, but ignore those people. Some talk about IPv6 fragmentation on a certain hardware platform. There was one about, too bad Ellen's not here, but there was a case where one of the root DNS servers, v6 advertisements out of China, was leaking to the public internet, so that was v6 related. There was something about people buying up the last remaining v4 address space to use botnets. There's one just in the last couple of days about using IPv6 address block about multiple locations, and that was a question about when you sign up to get your v6 address space, do you want to get a /48 for each site you have, or do you want to get a bigger allocation and divide it up? How do you do that? Useful advice there. And then there's also, every day or two, there's somebody who says, I can't get to such and such site on IPv6, it's broken. Somebody needs to fix it. Okay, so the final part I'm going to talk about, this is my personal opinions, which you probably guessed some of this from what I was saying earlier, what I concentrated on. v4 space is almost gone. That's a given. We all know that. You can see, watch the graphs, but you need to treat it as if it's gone and work from there. There are lots of schemes to extend the v4's useful life, address markets, layers and layers and layers of NAT. Ultimately, those just add complexity, and if they're not inherently unfair, they at least provide potential for people to game the system and take advantage that I consider unfair ways. We really need to transition to v6 to provide a level playing field like we had at the beginning of the internet days, so that we can all get our work done, we can all make money without stepping on somebody else in the process. v6 is almost ready. Not quite, but we're getting real close there. We've seen a lot of that. We'll see a lot of it during the rest of this, these few days. But we need to help. We need to make that happen. And here's how we do that. So there's a few problems that stand in the way. There's still some lack of CBE support. I was actually glad to see these numbers saying that we're starting to see some traction there. Right now, most of the v6 internet is still built around tunnels. That makes things work in the short term, but it provides suboptimal routings and MTU issues. We actually tried to do a little trial ourselves for IPv6 Day at my day job, and had to stop at the last minute because we ran into problems with MTU that we couldn't solve in time. There's a lot of back-end systems that need to be taught about v6. Another example from my own company is that none of our geolocation stuff understands a v6 address, so we can't tell where our users are, and we can't give them the ads that we want them to see. I don't think we're alone in that. Lots of solutions involving middle boxes that are coming along the way, but like I keep saying, I don't think that's the long-term answer. So here's what we do to help. Bug your providers and your vendors. Tell them what you want. If you have a bandwidth provider that doesn't provide v6, tell them you want it, and you want it today. Tunnel if that's all they offer, but native would be even better. Talk to your equipment vendors. If they don't have v6 ready, or if they want to charge extra for it, tell them it's too late for that game. It needs to be there now. Run a trial. That's what this whole conference is about, so I won't go into that too much more. But other than to choose a limited, manageable subset of your environment, make it v6 enabled on the content delivery side, on the user access side, whatever is appropriate. Try it for a while, fix some issues, and then do it again. Talk to each other, compare your experiences, get together in meetings like this, like NANOG, and explain, tell each other what happened, and work together to fix things. And you've also mentioned this, but we should have another IPv6 day or IPv6 week or whatever, because that provides an incentive for people to try this again. So, wrapping up, and again, sorry to be so long-winded, but NANOG is a group. We're collaborating to make the internet better. Please participate. Mailing list is free to join. There's interesting stuff on there. Watch the conference archives online. Come to a conference if you want, if there's one in your area, or if you can get funding to travel. It's a bunch of people who really who want to make things work, and that's the primary goal. So I'll ask if there's any questions. Yeah, guess not. So thanks.